Okay, so this is the video presentation for my applied project for the applied electrical and electronical construction project. So over here I have my flowchart for the facial recognition system. This is for the real-time facial recognition and identification using webcam. Firstly, what I did was to pip install the relevant libraries and import them into the code, as I've done so here already. Then I copy the hair cascade from a GitHub website and import my chosen cascade classifier to my code. Over here, my face cascade, which I downloaded from this website over here. And then I chose this face cascade in order to detect the frontal face in order to do the facial recognition. Then I converted the images to grayscale for use of the face classifier and used the face classifier to detect faces in the images. As you can see over here, I changed it to grayscale, and after that I used the face classifier to detect my face, the image, using detect multiscale, and I set a region of interest for my face in order to detect the coordinates of my face. Then I draw a rectangle in the OpenCV to display a bounding box of my face on the webcam. So over here, in order to do the facial recognition, I have to draw a bounding box over my face, which I have set here already for the color, the thickness of the stroke, and the coordinates of the rectangle, which has to be the same as my region of interest, as it wants to detect my face. Then I also set the rectangle over here. After that, I used the recognizer available in OpenCV to recognize my face on the webcam. So my recognizer is available in the hair cascades, and in order to train the recognizer, I have to create a new file in order to load test images and to train my recognizer in there. That's why I created this new facestrain.py file. Inside this file, I utilized the OSWalk for image finding and download images of several people into the new file for face training. So over here you can see I imported OS, and I used the base derivative from the OS path in order to find the file of the images and import the images inside. As you can see over here, I have the images over here, which has all the test images and the images of myself. After that, I obtained the labels of the images from the directories of the files, which I have done so over here for the root and the directories and the files in OSWalk. And then in order to safeguard and to make sure that all the labels of the images have been taken into my software program over here, I use this. If file as with PNG or JPEG, I will take it into the path, and then I will take the label as well. After I train the images into NumPy arrays using the NumPy library, as you can see over here, I change it to NumPy arrays in order for it to contain all the generic data in order to be initialized later. Then I set the region of interest as the face in the training data, which I've done so here. For the coordinates in the faces, I set it to images array for the region of interest. And I created two lists, the Y labels and the X train, in order to store the data for the region of interest and the IDs of the images inside of the list, which is over here, the created. And then after that, I created an empty dictionary to label the images for the training data. Over here, the label IDs, the empty dictionary. And in order to make sure that all of the label IDs of the images are inside, I created an if loop here, an if condition here, that states that if the label IDs of unknown images haven't been stored into the dictionary, I store it inside. Then I use the pickle library in Python to save the label IDs for the images, as you can see over here, using pickle IDs. I use the pickle dump to save all the label IDs inside the file. Then I trained OpenCV recognizer over here using recognizer.train for the X train and the Y labels list. Then I save it as face trainer. After that, I implement the recognizer in the main facial recognition code over here. As you can see, I implemented it inside using the LBPH face recognizer, and I loaded the recognizer for the trainer YAML that I saved in my faces trained. Then I load the label names from the pickle libraries to identify faces over here. I loaded the label names, but what I did was I inverted the labels for v equals to k for k, as the label names is not the names of the people in the images, it's the labels, so I have to display the names. After I use OpenCV put text to display the names of the known people and the faces appearing on the webcam. Using OpenCV put text over here, I created the text in order to display the names of the people, the font, the name, which is from the labels, ID, dictionary, the color, and the stroke. And after that, I add my own images into the training file for better accuracy and resize the images used for training. As you can see in my training file over here, I added my own images inside as I've shown you earlier, and after that I resized the images and used the final images as a pill image in order for it to be more accurate. After that, what I did was to add iCascade classifier to increase accuracy of the facial recognition program, as you can see over here, in order to display bounding boxes on my eyes as well. So for the next one, the flowchart for the offline facial recognition and identification using images, I opened up a different code using identify.py, and over here, I first installed the relevant libraries, the face recognition below, ported them inside the code, and I used the face recognition library to identify faces as I've done so here. I took an image of myself and I used the face recognition.load image file to load my image, and after that used the face recognition.face encodings to encode my face inside of the library. After I create an array of encodings and names here, which is my face encoding, and my known face names, which is my name. After that, I load the test images to find the faces in. Over here, for the test images to load, for the face recognition to load the image file, I loaded a group of people, including myself inside, in order to determine whether this offline facial recognition can work. After that, I wanted to find the faces in the test image, so I used the same thing. I used the face locations for the face recognition library to find the locations of the faces, and I used the face encodings in order to encode the faces inside the test image. After I converted the images into a pill format in order for it to be read easier, over here as you can see, then I created an image draw instance as well. After that, I looped through the faces and test images for matches to my known faces encodings, which is my face over here. So I loop through the faces and test images for top, right, bottom, left in order to find my face, and if there are matches, then I draw a bounding box over them. As you can see over here, I draw the box, and then after that I draw a label of my name inside the bounding box as well if it matches. If there's no match, then the name will come up as an unknown person. Then I display the image and I save the image over here using pill image. So I'm going to run that right now. One second here. It's in the face recognition exam. It's in the SRC folder, Python identify.py. So as you can see over here, I have my image of myself with my known name, and for these unknown people here, there comes up unknown person inside here, which shows. Okay, now next for my flowchart for the traffic recognition system. So for the traffic recognition system, what I did was at first install all the relevant libraries on OpenCV, such as the TensorFlow. As you can see, sklearn, matplotlib, all over here, import them into my code. Then I import the project traffic symbols to a training folder, which I've already done. Then I use the OS modules to iterate over the classes and append the images and respective labels in the data and labels list. I created a data and labels list here, and using OS module for the path here for the symbols, which is my project symbols, I append them into the labels list and the data list, as I've done so here, except for the error loading images. I also resize it in order to make it more accurate. Then I convert the list into NumPy arrays over here, as I've done so, in order to make it easier to be read, and also that it can contain all the generic data. Then I split the training and testing dataset and convert the labels into one encoding. As I've done so here, I split it in order for it to be able to train and test. Then I convert the labels into one encoding over here, as I've done so. Then I built a convolutional neural network in order to test my model, which I've done so here. I built the model out following a code online. Then I compile the model over here using the model.compile loss category. And then I use the Adams optimizer. And after that, I set the epochs to be 20 for it to run 20 times in order for it to be more accurate and obtain a stable accuracy and validation loss score. After that, I save my model as my model.h5. After that, I plot graphs for the accuracy of my CNN model, which I've done so here already. I plot the graphs out. One of the first graph, the y-axis, I set it as accuracy, and the x-axis as epochs. For the second graph, the y-axis I set as the validation loss, and the x-axis for the epochs as well. And then after that, I saved it all inside here, and I saved the model as traffic classifier.h5. So I'll go ahead and run that now. And as you can see, it's running. And over here, down here, I have run all the epochs, which shows all my training data over here. There's a total of 20. And over here, as you can see, all the epochs has been run. And I have obtained the accuracy of the maximum of 95 percentile, which is shown over here, the graph for my accuracy. And also, besides that, is my validation loss for my training data as well over here. Now, after doing that, I created a new code for my graphical user interface, my GUI over here, and I install the relevant libraries and import them into the code. As you can see here, CV2, NumPy, Tinker. Then I load the train model that I have already done. I load the train CNN model to classify the signs. So over here, from the Keras models, I imported the load model, which is my traffic classifier.h5. Then I wrote a dictionary to label all of the traffic symbol classes over here, which I have already labeled. Then I initialize the GUI. Over here, I initialize it and label it as well. Then I classify the file path. I show the classify button in the GUI and upload the image. So over here, as you can see, I classify the file path over here already for the global label path. I resize the image for better accuracy. Then use and change it to NumPy array for better reading in order for it to be initialized. Then down over here as well, I also show the classify button in order to make it more easily accessible, and also I also wrote the code to upload the image into the GUI over here. After that, I show the upload button and heading in the GUI, which is down here. I showed the upload button over here, and then after that, for the heading for the GUI down here as well, which is the know your traffic sign, which I have also created. Now for slide 9 in the traffic symbols provided in the project, I have to count the shapes. So I imported the relevant libraries for shape counting and find the font used to display the text on the images. So over here, as you can see, I imported CV2, which is the relevant library, and I displayed the font inside over here as well already, which is the font to display the text on the image for the shape counting. Then I load the shape counting image, get the threshold of the image, and find the contours of the image. So I've done so here already, which is using the image cv2.imread, which is to find the shapes over here. Now after that, I set the threshold of a limit of 200 and 255, and I found the contours. Then I loop through the contours in order to make sure that I know every shape's contours over here For CV2 and contours, I approximate the length and everything. I already look through all of them, and then after that I approximate the contours and label the shapes and the number of the shapes. So over here I approximate the contours to reduce the noise, and then I set an if condition and else condition and else if condition, that if the approximation for the total contours is 3, then I will set it as triangle. If it's 4, it's a square. But if it's more than 4, then or anything else, it will be a circle. After that, I display the shapes and the threshold on the screen here, which is after showing the images for and detecting the shape. I can then count the shapes, which I've printed down here already. Then after that, in order to and then after that, I add the shape counting to the GUI code using this if condition here. If the predicted class equals to 9, which is slide 9 for the counting images, then I will run this code over here in order to count the shapes of the in order to count the shapes in the image. So I'm going to run that right now. So as you can see over here for my symbols, so I run the first one. You see it says detecting the yellow line, and maybe over here for the green one, says it's detecting the green line. Also inside my I accidentally closed it. Let me run it again. Alright, and also for my other images such as this, when I press classify the image, then it comes out over here, stop the traffic light. When I upload another image, let's say I upload the one for counting the number of shapes, just this one over here, and I classify the image, you see the threshold of the shapes of the images and the shapes over here, which I've already said, which is it will detect the shapes and then it will state it inside the PowerShell. So over here I'll count the number of shapes, and there are 3 triangles, 2 squares and 3 circles. So that is all for my video presentation. Thank you.